Hello friends, welcome back. So today we are going to see how to solve the problems, the game theory problems of 2 by n and m by 2 games, basically which does not have saddle point. Okay, basically we have to solve these problems using graphical method, but however we will see the theory and let us solve the problem. So this is the second type of problems where you don't have when you don't have saddle point. If you have saddle point, then automatically you'll get the value of the game and the problem is over. The problem comes when you have such games and when you don't get saddle point, when you don't get a saddle point. Now what to when you don't get a saddle point, what do you do? Okay, that's the problem. Okay, so if there is a saddle point, then you will finish the problem there. If you don't get a saddle point, then you need to basically think what to do. Now when I say graphical method by 2 by n or m by 2 games without saddle point, this is the example for 2 by n games. This is 2 rows, that is the payoff for player A is, sorry, strategies for player A is A1 and A2, where there are, for player B there are n different strategies. So that's why it is called as 2 by n games. And when you see m by 2 games, there are, for player A you have m different strategies, and for player B you have only B1 and B2 strategies. Okay, so 2 by n and m by 2 games, how to solve, we will see today. Let us take this problem for example. This is basically a 2 by n games, so that means it is basically this type of game. Okay, you might get this type of game also. So this is basically 2 by n game. The procedure for solving the games remains the same. Just here and there you need to change a few things. So solving the following game, 2 by 3 game graphically, so that you will get the value of the game. Alright, so let us quickly go and solve this problem. Alright, so when you have such a problem, basically we need to see whether there exists a saddle point or not. So when I say row minima and column minima, so row minima is 1, here it is 2, column minima is column, this is maximum, this is row minimum, column maximum is 8, 11. So in that, this is the maximum, here this is the min max. So 5 and 2, so since min max and max min is not equal to min max, so there is no saddle point. Okay, there is no saddle point. So when there is no saddle point, you cannot get the value of the game. So what you have to do is, you have to do some treatment so that you will get the value of the game here. Now, so basically, for player A, there are 2 strategies. So I can write this as S of A A1, A2, and the probability is P1 and P2, right? Where P2 is equal to 1 minus P1. Now, here, out of these three, like for player B strategies, there is B1, B2, and B3 strategies. Now, out of which we need only two, because we can solve if we can reduce this 2 by 3 matrix to 2 by 2 matrix. We can solve using the games with no saddle point by 2 by 2 methods, as you have already seen in the previous videos. Okay, so basically our objective here is to reduce this 2 by 3 or whatever 2 by n matrix into 2 by 2 matrix. Now, how do we do that? Okay, so this has to be done graphically. So the payoffs for strategy A is you have B1 payoff equation, B2 payoff equation, and B3 payoff equation. Now these equations you have to plot it on a graph. Now you will have basically two lines, that is axis 1 and axis 2. Let me call this as axis 1 and let me call this as axis 2. Okay, now we need to plot these things, that is A1 and A2 here on this graph. The range is from 0 to 11. This is the highest numbers. So I will start with 0 here. You can even start with negative if there are negative signs here. So I'll start with 0, 1, 2, 3, 4, 5, 6, 7. Sorry. They are not uniform, so just do it again. So 0, 1, 2. Five, okay, 6, 7, 8, 9, 10. And this is 11. So almost I have drawn the points here. Now let us plot these things on axis 1 and axis 2. So from A1 to A2, A1 is 1. So I'll take A1 on axis 1, here it is 1, and A2 on axis 2, that is 8. Okay, 1 and 8. So I need to draw a line from here to here. Okay, so basically I've got a line. Okay, this is the line. From 3 to 5, 3 and 5 here. Okay, then from 11 to 2. So this is 11 and I need to draw a line till 2. So you have drawn the lines. So this is the first line, that is 1 and 8. That is the B1 equation. Okay. Then 3 to 5, that is B2. and Lagrange 2 is basically B3. Now, when you have drawn this thing, uh, when you draw the graph, since it is the 2 by n payoff matrix, you need to consider the lower part of the envelope, lower envelope. If it is m by 2, then you have to consider the upper envelope. Since it is 2 by n now, I will take this lower envelope, the area which is below these points here, where all the three lines join. So I'll consider this area. Now this is called as your lower envelope. Okay, it's your lower envelope, and this we are taking because it is a 2 by n games. If there is a m by 2 games, you have to take the upper envelope. You have to take the upper envelope. Okay. Anyway, now the payoffs for A is, this is out of A is getting the minimum gains. Out of the minimum gains, the maximum gain of the minimum lies here at this point. So I will put that particular point as H. So this is the point. So this is the point where I am getting the maximum gains out of these minimums. These are all minimums of the maximum. If it is a m by 2, then it is out of the maximum loss. What is the minimum loss? I click the minimum loss here. So out of the minimum gains, the maximum of minimum lies here. Maximum of these minimum lies here. Now, this particular point is an intersection of this line, that is B2, and this line, that is B3. So the optimal strategies, what you get is, you have to write like this, that is optimal strategies, what you will get is at, now B1 will be 0. You have to nullify this because you are not going to get the optimum strategies for player B at B1. So B1 we are taking it to 0. Then B2, Q1, and B3, Q2, where Q2 is 1 minus Q1. Now you need to solve the game like this, basically. So you have drawn the graph. Anyway, I'll take this off. You have got your optimal strategies. The optimal strategy for player A and player B, you have already got it. Now, hence, the payoff matrix for player A and player and the payoff matrix, that is 2 by 3 matrix, get reduced to 2 by 2 matrix, that is sorry. Okay, so now you've got this. Now, here 2 by 3 matrix has been reduced to 2 by 2 matrix. So main objective was to reduce from 2 by 3 to 2 by 2 matrix. So once we got the 2 by 2 matrix, we have to again check whether there is a saddle point here. If there is a saddle point, then we'll stop here. This is row minima. This is column maxima. So row minima is 3, 2, column maxima is 5 and 11. So max of min, this is maximum, and this is your min max. So 5 and 3. So there is no saddle point here. So you are not getting the saddle point here also. Now what you have to do is apply the formula to get the P1, P2, Q1, Q2, and then the value of the gain. So you already know. So if you don't know, then watch the previous videos how to solve the 2 by 2 matrix games. This is the 2 by 2 matrix without saddle point. Okay. Once you apply the formula, so it is 2 minus 5, 2 minus 5 divided by 3 plus 2 minus 11 plus 5. If you solve this, you will get it as 3 by 11. Then you also know that P2 is equal to 1 minus P1 is equal to 1 minus 3 by 11 minus of 3 by 11, that is 8 by 11. So P1, P2 is 3 by 11 and 8 by 11. And similarly, Q2 is 2 minus 11. So basically you will get as minus 3 by 11, and it is basically minus 3 by 11 and minus 3 and divided by minus 11. So you will get the total as 3 by 11 itself. It's 5. So Q1 is to minus 9 divided by minus 11, that is 9 by 11. Sorry, this is not Q2, this is Q1. So Q2 is equal to 1 minus Q1, 1 minus 9 by 11, that is 2 by 11. So you have already got these things. Now, finally, I'll take this off as of now. And finally, the value of the gain, that is equal to 3 into 2 minus 11 into 5 divided by 3 plus 2, 11 minus 11 plus 5. If you solve this, minus 55 divided by minus 11, that is minus 49 divided by minus 11, that is basically 49 by 11. Okay, you got this. So you have find the value of the gain. So now last thing what you need to do is write the strategies, optimal strategies, and the value of the gain in the conclusion part. How do we write this? So the conclusion is the optimal strategies are strategies for player A and player B are for player A strategy are 3 by 11, comma 8 by 11. Now optimal strategies for player B is, so first one is B1 is 0, so put 0, then it is 9 by 11, and Q2, Q1, Q2, that is 2 by 11, and the value of the game is equal to 49 by 9. So finally, you have got the optimal strategies for player A and player B. These are the strategies for player A and player B. And you also got the value of the game. And this is how you need to solve a problem when you get by 2 by 3. Sorry, 2 by n or m by 2. You need to plot the graphs. And when you don't get the saddle point, you need to plot the graphs and reduce it to 2 by 2. Check whether you get the saddle point here. If you don't get it, apply these formulas and arrive at the optimal strategies and the value of the game. So thank you for watching. We'll see each other in the next video. Thank you.